Welcome to MSUA Game Changers webcast, where we speak with satellite and mobile connectivity thought leaders about industry trends and share what you need to know about the future of mobile satellite communications. I'm your host, Roger Lanto, and I'm excited to introduce Steve Richeson, Vice President Growth at Sat-Lite Technologies. We know Steve from his time at MSUA member Mission Microwave. He's now joined Sat-Lite Technologies, a leading provider of parabolic aperture antennas. Sat-Lite Technologies was an exhibitor at the recent Satellite 2026 show in Washington, D.C. The company is benefiting from the renewed interest in multi-orbit and multi-frequency solutions arising from the increasingly diverse satellite landscape. But first, Steve, tell me about your professional journey and where satellite technology became a part of your life.
Great, thanks, Roger. Good to be here. Appreciate the invitation based on the legacy of working with MSUA on Mission Microwave. That was a great experience. I've got 40 years in the satellite business. A fun origin story because it actually involves one of my competitors now. I was hired into the satellite business by Jim Oliver, who was the founder of AVL Technologies back in 1987. And most of our listeners won't recall, but prior to that, I was working in the oil industry from 1984 to 1987. And if you're old enough to know what happened to the oil industry in 1987, you'll see why the satellite industry was really attractive. So I ran into Jim Oliver at a Georgia Tech Alumni Career Fair. He was a guy standing in front of a little booth with a Smith chart logo on it, and I was probably the only other person in the room who knew what that was. And he hired me as a field engineer, and I've been in the satellite industry since 1987. And it's just a lot. There's always a lot going on. Sometimes it's a little more dynamic than others.
Pretty dynamic lately. So where does Sat-Lite Technologies fit in the market value chain today?
Well, that's great, and we really like to have the opportunity to explain that because we sell antennas, right? An antenna, that's a reflector, a feed, the mount, we integrate the control system on that. That's a really visible part of a terminal, but it's actually our customers who make the satellite terminals. Our customers are OEM terminal manufacturers, all the large ones, and system integrators. You don't see our logo out there in the field a lot, but you see our antennas all over the place under other people's logos. And that's the level we work at. We're a manufacturer, right? We're not in it for the glory. We're in it for the money, right? So we're getting into a lot of places, and because of that, we stay, in our lane, right? We don't compete with our customers because we're an enabler for those customers, and we want to enable all of them. And so, our customers do compete with each other, of course, but we do unique things for each of our customers, and they come to us with bespoke requirements to help them differentiate. And using our 20 years of experience, our product platforms, our design expertise in the antenna manufacturing, the feed design and manufacturing, the control system integration, we can bring a unique solution to them to help them differentiate their terminal offer in the market. One of the interesting things about being on this position in the value chain, which is really identical to what I did at Mission Microwave, is that you really learn a lot about the terminal business, the terminal and the gateway business. You learn a good deal about that because you're selling into all these customers that differentiate themselves in that. But what that does is actually gives you a great understanding of the complexity and the value that those customers add. And we understand that, which is why when we're asked, do you compete with your customers? It's like, do you know what our customers do? It's really hard. I mean, what we do is really hard and really unique. But what our customers do, they add a tremendous amount of value integrating these systems into a usable, certified terminal that can work plug and play in a satellite network. That's a long ways for making an antenna. So that's our position on the value chain. It's a surprisingly exciting place to be. It is very high tech. It may not sound all that sexy, but there's a tremendous amount of math that goes into the design. And like anything in radio frequency manufacturing, the trick isn't to be able to create and tune up something. The trick is to be able to make 30 of them a week and have them meet spec and performance. That's the magic in the manufacturing of RF. And Sat-Lite Technologies has built a tremendous legacy in that, through supporting these OEM customers.
And how has the market for satellite technology evolved, and how has that impacted what you're delivering?
Well, it's changed a lot. I mean, the company started out primarily doing satellite news gathering vehicles, right? That was it was a really strong play at everybody in the value chain at that point, us and our competitors. Satellite news gathering um, was a really booming industry. That's really gone by the wayside. There's transportable antennas are still quite a big thing. I mean, that's how fixed antennas are less of a thing, actually, because a big antenna nowadays is 4 meters. Um, there are bigger ones, but the mass market tends to be 4 meters and smaller. The It's evolved completely away from satellite news gathering kind of applications. Obviously, in the last 5, 8 years, the introduction and success of the LEO networks has significantly changed the way our customers interact with the satellite networks, how they deliver the services they're delivering. I mean, you've had the traditional um, encroachment of terrestrial technologies. I mean, for example, satellite news gathering was a big part of the business. You'd see trucks parked outside stadiums, and at some point in the 2010s, people figured out that stadiums don't move that much, and they've really sophisticated fiber rings running through the stadiums right now. You'll still see satellite news gathering vehicles out there, but they're just backups. Um, in the transportable business, there has been a lot of growth in cellular emergency services, right? You'll see these kind of antennas on the carriers, AT&T, Verizon. You'll see transportable, what looks like satellite news gathering antennas used for cellular backhaul replacement in emergencies, or cell on wheels applications where they're used by emergency services. That's kind of taken the place of the satellite news gathering business. So, but transportables have really taken the place of vehicle mounted stuff. We still do both, but the growth has been in transportable and precision reflector designs.
And since you mentioned LEO satellites, how has satellite technologies been impacted by the increasing emphasis on vertical integration?
Well, the big players are completely vertically integrated on the terminal side. That's not completely true on the gateway side, right? Satellite constellations need a large number of gateway antennas. Those are larger, high performance, high quality, industrial infrastructure kind of antennas, and that's the market we serve. And there's a lot of applications in that. And it's not constellations aren't just Starlink, right? I mean, obviously there are gateways in Starlink, there are gateways in Amazon, gateways in Telesat, all of those operators. But there are also constellations that don't do communications, right? Earth observation constellations, and we see a growth in particularly multi-band, multi-orbit kind of antennas. So antennas that can track anywhere in the sky and work with some interesting combinations of frequencies to do Earth observations.
Funny you should mention that. So how is spectrum usage evolving, and how is that impacting satellite technologies?
Well, it's evolving as it's kind of always evolved. More is more, right? The industry evolved from C to X and KU and then KA. When I started in the industry, we were just introducing large KU band antennas when I worked for Radiation Systems, Satcom Technologies. And I went around the world building large KU band antennas, and that's not real high tech anymore. So the industry advanced to KA band. At Sat-Lite, we're supporting everything from L band, which is like 1.5 gigahertz, up through Ka band at 30 gigahertz today, commercially. The next big thing is Q and V band. There are constellations that will use Q and V band. Not all of them US based, but there'll be interest in the US in keeping an eye on them. And so Q and V band is kind of a technology driver at the moment. It's not really commercialized yet. It's similar cycle that we went through with Ka band. There's a skepticism. Will it even work? Right. And you kind of get over that. It maybe takes 2 years, maybe takes 8 years. You get over that. And then can you make it commercially? Can you make it repeatably commercially? And we're really ahead of the curve working on that. We don't have commercial products today at Q&V band, but we understand the boundary conditions of that really well. And we are talking with our customers about how to support their requirements in Q&V band. So that, stay tuned for that. There'll be some fun product announcements about that, right? We're doing the math right now. Again, building something, yeah, it's doable. A lot of smart guys get together, you can build one of anything, but can you make it a viable, commercial, repeatable, deliverable product? That's a separate question. The answer to that's yes. It's just how long does it take?
And what are the main markets for parabolic aperture antennas?
Well, it's a lot of it's still the same markets, but the terminal side of it, right? The VSAT side of it, like you used to see VSATs on gas stations that were typically big applications. I mean, they're still there and they're still in use, but certainly not a growth business. The growth side of the business is in the gateway business. It's also in some areas that are more defense oriented regarding signals intelligence and electronic warfare, being able to point a lot of power at a specific satellite. And that's where parabolic antennas really shine, actually, because there are two things involved in tracking and using a satellite. The gain is how you close the link. Do you get enough power there? That's pretty easy in a LEO network. These things are only 500 kilometers away, right? You could hit that with a AA battery. But directivity is still a function of aperture. Directivity is how narrowly you can point the beam. And as space gets more and more crowded, that becomes more and more important because you have to be able to point at just one thing at a time and point it accurately so you can either track it or perhaps interfere with it, do what you will. So parabolic antennas aren't going away. They're actually finding quite a niche in that. It's in the flat panel world, you can do all those things with a ginormous flat panel, but is it, those things we talked about, is it commercially realizable? Is it repeatable? Is it serviceable in the field? And that's where traditional parabolic architectures really shine. Customers are really comfortable with that. You take a giant monolithic flat panel antenna and nobody knows how it works. The lights are green or they're not. And that's great when it's a $100 user terminal. You can throw it away, put it in a new one. When it's an $8 million antenna you're using for tracking and SIGINT and electronic warfare, not so great. So smaller parabolic apertures, say 1 meter to 4.x meter, something like that. That's a hot segment.
And what is the market outlook for flyaway antennas? And what is a flyaway antenna?
Yeah, well, that's a great question. A flyaway is, you can fly almost anything away if you got a big enough plane, right? And typically flyaways mean two things. There are small ones which have really been encroached on by the LEO market. So small airline checkable ones, or carry-on even. And then there's the flyaway ones that are checkable, and then there's some large flyaways that we do for customers that they do fill on a pallet. You can fly them away. A couple of guys can put them together in an hour. Those things can be over 4 meters in diameter. So big ones. Typical things involved in flyaways. They're designed to be taken apart and put together without being optically realigned in the field. So you've got a lot of precision parts that you need to be able to take apart, put back together, and have them repeat that same really precision reflector architecture out in the field. That means they're a little bit pricey. They're hard to design, but that's where the experience comes in working with those customers. And how do you make something that you can take apart, put together 100 times, and it'll still be accurate within a few thousandths of an inch on the surface? That's so. What a flyaway is something you take apart and move and put back together, as opposed to when you're driving down the road and you see the big earth stations and teleports. Those are not transportables, right? They have a 7-ton king post bolted into a concrete foundation. You're not going to move that. A flyaway, you could take it and move it somewhere else in a day, right? And that actually is pretty valuable because people like to be able to move things around, both tactically and for a lot of other more commercial reasons.
So what is the next event that you'll be attending?
We're going to the Small Sat show in Utah. We actually will have a booth also at the Singapore show. It goes by a lot of different names, traditionally called Communicasia, Satellite Asia this week, I think, is what it's called, and ATXSG or something. We'll be at that one. We were going to be at CavSat. That's moved to October now. So we've got an active trade show schedule, and we're always out talking with customers. A lot of customers come in and see the plant. We routinely run some of our larger customers through factory acceptance testing. The picture in the background is an example of a factory accepting test event we did for a customer.
And where can people find out more about Sat-Lite Technologies?
It's pretty easy these days, right? Sat-Lite Technologies, or leave out the dash. You'll probably still find it. Sat-Lite Technologies. We're antennas from Texas, right? We're over in White Oak, Texas, and it's an expanding factory.
Where is White Oak?
It's would it help if I say it's a suburb of Longview? It's East Texas. It is East Texas,
Okay.
and so we have land. We're putting new buildings on it. We're expanding. I mean, these are the market. The challenges in the market right now are what we would call smiley face problems, right? They're fulfilling demand. We can always try to capture more of it, but building and delivering on schedule, we have a great reputation for that. It's always a challenge, and the factory has to expand to do that. Again, this is RF design. It's not about designing it and building one. It's about repeatedly delivering in quantity for the customers, and delivery schedule is a huge differentiator in this business.
Okay, Steve. Well, I'll look forward to seeing you at one of these shows down the road. I want to thank the Mobile Satellite Users Association for hosting these sessions. You can learn more about the MSUA at msua.org. You can learn how to get our weekly newsletter that gives you updates on everything that's happening in the industry and shares information about upcoming events. And you can also find out how to become a member. We look forward to seeing you next time on MSUA's Game Changers webcast. Steve, thanks a lot for joining us.
Thanks, Roger.